Hello, and welcome to this lesson on solving compound inequalities. So this is the next step of inequalities, past multi-step inequalities. It's really not that terribly hard, to be honest with you. It's going to be a lot of the same stuff. So how do I solve compound inequalities? Pretty basic, straightforward, and essential question. Did you know that many problems involving inequalities may not look like they do? Like, I need at least 5 chairs for a party. Well, chairs would be greater than or equal to 5. Billy hasn't even done 10 push-ups. So, the number of push-ups is less than 10. These 2 boxes need to hold more than 40 magazines. So, 2 boxes should be greater than 40. This campfire will burn at most 2 hours. The fire will be less than or equal to 2. So it doesn't always have to sound like and have the words greater than and less than to make it a inequality. Okay, we have a new vocabulary here, compound inequality. It consists of 2 separate inequalities separated by and or. And it says there, an and inequality, you're looking for the solution of both, and or you're looking for the solution of one. And I'll make sense of that here in a second. So this is an and inequality. You see it very clearly, and. Now the way we graph that is we would actually take each of these inequalities, this one, and we graph them kind of separately, but on the same number line. So for example here, x is greater than -2. So now when I'm going to graph this, I need to put both -2 and +1 on this same number line. So this sometimes gets a little hairy. Okay, so I'm going to do this. -2, -1, 0, 1, and then there's a -3. Okay, so I have -2 over here, +1 over here, and there we have it. So now, it says from -2, I need a hollow dot. And from -2, I'm going to be shading greater than, which would be to the right. Now, if I change color to red, now we're going to graph the red one. So I need a solid dot at 1. And from that 1, I'm going to be shading less than, which is to the left. Now, where are both of these true? Because I want to know what numbers are greater than -2 and less than or equal to 1. Both of these need to be true. So where on my graph would both of them be true? Well, it would be between the 2 inequalities. So really, the solution of this is that. Just the area between 1 and -2. These are the numbers that are bigger than -2 and less than or equal to 1. So that's what one of the definitions up above was saying, the and inequality. You're looking for the solution of both inequalities. Both pieces must be true. Both this one and this one must be true. So these are the numbers that make both of them true. Now an or inequality. So the first thing I'm doing is I'm numbering my number line to get both 0, here's 0, and -1 on the number line. So I can see from 0, I'm going to get a solid dot. From -1, we're going to get a hollow dot. So each number gets their own dot. They get their own shade. They get their own everything. They don't have to be connected together. Now this from here, since I have my blue out still, I'm going to do this one. So x is less than -1. So from -1, if I shade less than, that is to the left. And x is greater than 0. From 0, I'm going to shade greater than. That greater than is to the right. And this is very different than the previous problem, because now you see how they're not connected? Like each inequality is kind of facing away from each other. And that's okay. And the solution here is still actually everything in the shaded region, because with an OR inequality, think about it. If I want a number bigger than 0 or less than -1, well, 2 is bigger than 0 or less than -1. -2 is bigger than 0 or less than -1. Because or means like if your mom said, hey, I want you to go to the store and you get white milk or chocolate milk. She'd be happy as long as you got white milk or chocolate milk. Now, if you came home with, I don't know, almond milk or something, she'd be pretty upset. But if you got one of those things, as long as one of those is true, you're good. Well, that's the same thing here. As long as you're the shaded region, like 2 here, as long as it's an answer to one of these, you're good. The only numbers on this entire graph that are not solutions would be between -1 and 0, like -0.5, right here, -0.5. He would not be a solution to this inequality because he does not make this true and he does not make that true. Okay? Now, you're going to see over time a very clear pattern on how and or inequalities look. And inequalities almost always look like you're shading between the 2 dots. You're shading, I call it shading on the inside. So you're shading on the inside. That's what an and inequality almost always looks like. And or inequality almost always looks like you're shading on the outside. So that can make it a bit easier for us to graph it once you know these little patterns, little tricks. So we want to write and graph the compound inequality. So all real numbers that are greater than -2 and less than 3. Okay, all real numbers that are greater than -2 and those numbers are less than 3. So I'm using x for the numbers, the thing we don't know. All real numbers greater than -2, boom, and those same numbers are less than 3. So I wrote it like this. I'm going to graph that. So the first thing I'm going to do is think of what numbers, what scale should I use on my number line to get from -2 to 3. And I'm thinking I'm going to count by 2's here. So I'm going to put 0, 2, 4, -2, -4. So then 3 would be, oopsie, 3 will need a hollow dot. And -2 will need a hollow dot. And my shade, I recommend not always just trying to figure out the and the or and shading inside and outside. I honestly, I look at the inequality, like from -2, I'm shading greater than. That's shaded, that's pointing on the inside. From 3, it's shading less than. That's on the inside. So guess what? I'm shading on the inside. And inequality is that. Now, before I go too much farther, there's a thought going through my brain that I should show you the other way you could write this. It's a bit more complex looking, but you're also probably going to see it more often. I know you're going to see it in this lesson. So the other way you could write this same thing is like this. Here's the trick that I do. So you put the numbers in order from least to greatest. This only works, by the way, with and inequalities. Now, this x is less than 3, x is less than 3. X and the thingy -2. Do you see how it's opening towards the x? So it's basically like we took this one and flipped it around. We got that. So here is this one. And here is that one. But it's kind of wrapped up together in one inequality looking thing, as opposed to two separate inequalities. So it's just another way, but it's a way that you're going to see and you're going to have to use, and you're going to have to understand what this means. Even if you don't want to write it right now in our very first problem of the lesson, I'm okay with that, but I wanted to show you. All real numbers that are less than 0, okay, so numbers less than 0, or those same numbers, or greater than or equal to 2. Greater than or equal to 2. So we got numbers that are less than 0 or greater than or equal to 2. And there's our big old or buddy. Okay, so 0, 1, 2, 3, -1. I found a way to get 0 and 2 on the number line. We prefer to not have our numbers on the very edge. Like here, it's not on the edge. This one, it kind of was. I put the 1 on the very far side. It's okay to a degree. Most number lines actually aren't this small. The ones that I made for the lessons are, because I don't like having big, huge monster number lines. But a lot of places, homeworks and tests and quizzes and stuff, the number lines will be bigger. All right, let's see. I'm going to put my dots. So 0 gets a hollow dot. Jump. 2 gets a solid dot. And my shade. Now, I can guess, because this is an OR inequality, I'm probably going to be shading on the outside. But I like to check it. From 0, I'm shading less than 0. This is less than 0. From 2, I'm shading greater than 2. Greater than is to the right of 2. That is on the outside. So there we go. Greater than 2, less than 0. That is our graph of this. All right. 2 for me, 1 for you. Why don't you go ahead and pause the video, do this problem right now. So you're going to do what we just did. You're going to write the inequality, then graph it, and when you're ready to continue, hit play, and we will go through it together. All right, so let's see here. All real numbers are less than or equal to -3, greater than 0. So numbers that are less than or equal to -3, and those same numbers are greater than or equal to -8. This is the one way to write this. The other way would be, this is how I start. -8, -3, this one's smaller, like putting them in order from least to greatest. And the reason why the x is in the middle, because x is going to be between -8 and -3. Now you just put in the right symbols. Boom, boom. This is the same as this. Mathematicians a lot of times like this because it takes up less space and it's less writing, even if it's a little bit more confusing. But we're kind of lazy people. We don't like to write too much. All right, so either you have one of these. Now, where do we put the numbers? What numbers we need? Well, from -3 to -8, I could go -3, -4, -5, -6, -7. I guess I can't even do that. So counting by twos is probably the thing. -2, -4, -6, -8, -10. So that would put -3 right here. That would put -8 right here, and they both do get solid dots because of the inequality. And it's an and, so I'm probably shading on the inside, but from -3, I'm shading to the left, less than. From -8, I'm shading greater than to the right, and both of those are facing inward. So that is our graph. Okay, so that's the most basic type of problem where they just kind of give you a word problem and you write it and you graph it. Now, if you could take a minute and try these two if you'd like to, if you need a little bit extra practice, go ahead and pause and try them. All right, this one would be x is less than -1 or x is greater than or equal to 4. That would look like -2, 0, 2, 4, 6 is the scale I'm going to use. That puts -1 right there, +4 right there, and it's an or, and I will be shading on the outside. I can also look at the symbols and decide which way I shade. Number 2. All real numbers that are greater than or equal to -3, and those same numbers are less than 5. That also could be written like this: -3, x, 5, and dund, and dund. So that is also a way you could write this same inequality in a shorter space. -4, -2, 0, 2, 4. So counting by 2s doesn't even work. So maybe 3s. So -6, -3, 0, 3, 6 gets a solid dot at -3, gets a hollow dot at 5, and it's an and, so I'm probably shading on the inside, and I can tell from this, bigger than -3, smaller than 5, I am indeed shading on the inside. All right, now let's do some solving. We need to take this inequality. See, now you're being forced into this type where it's like 3 things in one. We're going to take this inequality. We are going to solve it, like solving an equation, and then we're going to graph our solution. Now, it is not as bad as it seems. Your goal is the same. It's to get this variable right here by itself. So you need to get rid of these 2 things, the -3 and this 2. You would do it the same way you would do before. Like if you would imagine like covering up this 1 with your hand, if you would solve just this inequality here, what would you do? Well, you would start by adding 3 to both sides, because you get rid of add and subtract first. The only difference is, instead of adding 3 to both sides, you add 3 to all sides. Okay, let's do that. So you got -2, 2x, and 4. So -5 plus 3 is -2, 1 plus 3 is 4, and when I added 3 here, this piece canceled out. Okay, to get this x by itself, we're going to divide by 2. Cancels. Oopsie. Cancels. Divide by 2 on all sides, everywhere. That gives me just a plain old x in the middle. That gives me a -1 on the left and a +2 on the right. And that's it. That honestly is like the hardest type of problem in this whole lesson. And now we graph. So I need -1, 0, 1. That'll work. -1, 0, 1, 2. I don't really like having the 2 on the outside, but it's okay. I need a solid dot at both 2 and -1. Solid dot, solid dot. From 2, so I'm looking at, I'm looking at this. From 2, I'm shading less than to the left. This other inequality, this one here, do you see how the variable's on the wrong side? If you're just looking at this, ignore the 2 now. This right here, -1 is less than or equal to x. Well, if we would normally take that and flip it, x would be here, the -1 would be there, and then we'd flip the direction of the inequality. Well, now this says, from -1, we're shading greater than to the right. And that shows us that these are both kind of facing inward. This is an and inequality. That is our solution. And I showed you before that this is what an and inequality almost always looks like. And inequalities shade on the inside. That is what an or inequality looks like. They always have the word or. And these or inequalities almost always have 2 completely separate inequalities. So I'm just going to solve this one. I'm going to solve this one. But I'm going to graph both of their answers on the same number line. That's it. So I'm going to solve this side first. -3, -3, 2x is less than 6, divide by 2, divide by 2, x is less than 3. Easy. Hopefully. Other side. You're going to give yourself a 3-second head start and see if you can beat me to the end. 1, 2, 3, plus 6, plus 6. 3x is greater than 18. Divide by 3, divide by 3, x is greater than 6. Did you win? So here are the 2 solutions. So now we just need to graph that on our number line. I'm thinking what numbers to put here, like 2, 4, 6, 8. I think would actually work fairly well. And 0. That would make a hollow dot at 3 right there, a hollow dot at 6 right there. And we can see this in or inequalities, and we saw that or inequalities almost always shade on the outside, but it's worth checking. From 3, we're shading less than. Yep, looks like we might be right. From 6, we're shading greater than to the right. Yep, we're definitely right. Okay, so or inequalities are nothing to get all worked up about. You solve them both completely separately. You graph them on the same number line. Almost always you'll be shading on the outside. And inequalities, though, are something to kind of be cautious of. Now, if this idea of solving all 3 sides is a mess to you, although I recommend honestly giving it a good honest attempt because it will be much easier. But if that's really a mess to you, the other thing you can do is you could actually take this and separate it back out into 2 separate problems. I'm going to show you what it looks like when you separate it, but then I'm not going to solve that because honestly it's a mess. So the 1 inequality is basically just that. So 4x minus 5 is less than or equal to 7. And you could solve that. The other inequality is that. -5 is less than 4x minus 5. And then you would solve this one, and then this one separately, and then graph them. But that's kind of a pain in the butt, because you'll be doing a lot of the same steps. Like, look, the first thing you'll do here is add 5 to both sides. The first thing you'll do here is add 5 to both sides. And then you'll divide by 4, and then divide by 4 to get your answer. Where if you do it the way I showed you before, it cuts down your work. Watch. Add 5 on all sides. 4x is less than or equal to 12 is less than 0. Divide by 4 on all sides. 3x 0. So that's less work than doing it as two completely separate problems, although you can. And if you don't like this, you can separate it out, but you do need to understand that this is an and inequality. Ors, you'll always see the word or. Ands almost always look like this. So as I'm graphing my and inequality, I'm going to count by twos. I could have counted by ones, and the 3 would be on, oh, I said 3 and I wrote it. The 3 would be on the outside, but I don't really like it on the outside. So there's my 3. I'm going to erase this. So there's 3, and actually he should be a solid dot, not a hollow dot. 0 gets the hollow dot. And it's an and, so I'm almost definitely going to be shading on the inside, but I check. From 3, we shade less than. From 0, oh, he's backwards. He's better. From 0, I'm shading greater than. And there we have it. See, I turned this one around because the x was on the wrong side from 0, so I flipped it, including the inequality, and there we go. If you ever get both your arrows are facing the same direction, something's probably wrong somewhere in the problem. Maybe you forgot to switch the inequality if you divided or multiplied by a negative. Yeah, that thing still exists. Maybe you have this mistake and go, oh wait, they shouldn't both be facing the same way. They very rarely, very, very, very rarely ever face the same way. It's possible, but not very likely. All right, so here's one for you. So why don't you go ahead and pause the video, do this problem on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so this is an or inequality, so we'll probably be shading on the outside. I'm going to solve the left one first. Minus 4, 3m is less than 6, divide by 3, m is less than 2. Plus 5, m is greater than 10. So that's the solving phase. Graphing phase. Scale. 0, 2, 4, 6, 8. 3, 6, 9, 12. It's not really good scale here. Everything's going to be a little wonky, so I guess I'm just going to pick 0, 4, 8, 12, 16. That puts 2 right here. Between 0 and 4 would be 2. And then between 8 and 12 right here would be 10. So let's make him a little bit shorter. Oopsie. Forgot to turn the sound off. There we go. So those where our lines would be to 10, our dots, and then we're shading probably on the outside, but look, from 10, greater than, away from it on the outside. From 2 is less than on the outside. Okay, try another one. Remember, this one is an and inequality. Go ahead and pause the video. Try. I encourage you to try keeping it together and not breaking it apart. But go ahead and do it right now. Okay, so let's see here. Jump. Minus 3 first, because you always get rid of the adds and subtracts before multiplies and divides. 2x is less than or equal to negative 4 is less than or equal to negative 8. Divide by 2, divide by 2, divide by 2. X is, let's do the left side first. We got negative 4, and on the right side, negative 2. I did not divide by a negative. I divided by positive 2 on all sides. If this was a negative here, if this guy was a negative, and I had to divide by negative 2, I would have to change the directions of these inequalities in the middle of the problem. But that did not happen yet. It will probably happen at some point, though. So let's see. Negative 2, negative 3, negative 4, negative 5. That puts a solid dot at -2, a solid dot at -4, and we should be shading in between them. From -2, we're shading less than. That's in between. From -4, we're shading greater than when I flip it around, so the variable's on the correct side. And we knew that because this was an and inequality. And inequalities get shaded on the inside. All right. I believe this is probably the last one of this type before we move on to applications. So go ahead and do one more time, pause the video, and let's get it done. All right, here. So add 3, so we get rid of adds and subtracts first. That gives us -6 is less than 3m is less than 6. Divide by 3 everywhere. That gives us -2 is less than m is less than +2. I would count by 2s, so 0, 2, 4, -2, -4. So we're going to get a hollow dot at 2, a hollow dot at -2, and we'll be shading in between. This is an and inequality. From +2, we're shading less than, which is in between. From -2, when you flip this around, you're shading greater than. That is also in between. And there we have it. I forgot about these two. Yeah, so let's try these two out real quick. So pause the video. That's just one more and, one more or, just kind of sinking it into our brains, making sure we're good. So try these two quickly, and then we'll move on to the applications. All right. So -2, -2, -2, -3 is less than or equal to -5t, which is less than or equal to 2. When you divide by -5 on all sides, some bad things happen. Like, first off, we're going to get fraction answers. We're going to get 3/5 and -2/5. Oh, nope. I dropped my negative in the problem here. No, I didn't. No, I didn't. It's going to be -2/5. So we got fraction answers, which, Secondly, because right here we divided by a negative number, we need to change the directions of our inequalities. Now, how would we graph something so horribly and ugly? That's a good question. I'm going to be counting by like either 1/5 or 2/5. I'm thinking I'm going to be counting by 2/5 because these numbers are fairly far apart. Counting by 1/5 is not going to work. So think of this as like counting by ones. Ignore the denominator. Since the denominators are the same, ignore. Imagine you're going from -2 to +3. What would you count by? 2, 4, or -2, 0, 2, 4. Yeah, let's do that. So -2, 0, 2, 4. That'd be a -4. Then you throw a 5th under each of them. So I counted by 2/5. That wasn't that bad. -2/5 gets a solid dot. +3/5 right here would get a hollow dot. And since it's an and, we will be shading on the inside. All right. Or let's change to blue. Let's go through this quick. -1, -1, 4c is less than or equal to -4, divide by 4, divide by 4, c is less than or equal to -1. +3, +3, 5c is greater than 20, divide by 5, divide by 5, c is greater than 4. I can go quick because you should have already done this. Let's see. Negative 2024. Sure, negative 20246. That puts a hollow dot at 4 right there. That puts a solid dot at -1 right there. That's -1. And then we should be shading on the outside. It's an or, but I can look. From 4, we're shading bigger than. From -1, we're shading less than. And there we have it. Okay, just a couple more practice problems under our belt. Took us 5 minutes. All right, applications. The temperature on Mars has a maximum of 27 degrees and a minimum of 133. Write and graph an inequality for the temperature on Mars. All right. And these are degrees Celsius, not Fahrenheit. So 27 degrees Celsius is like 60, 50 degrees, something like that. I mean, 100 degrees Celsius is boiling. 0 degrees Celsius is freezing at 32. So this is bigger than 32 degrees. So that's like the same temperature we have here in the winter time. That's their hot. And then cold, well, that's extremely, extremely cold. So, X, something with 27 and a negative 133. I'm putting those because in this order, because the temperature is going to be between these two. So this is going to be an and inequality. 27 is the maximum. Negative 133 is the minimum. So if the maximum is 27, it can be less than or equal to that. And the minimum is 133, so that it could be equal to that. That would be the compound inequality. Or if you wrote it like this, x is greater than or equal to negative 133, and x is less than or equal to 27. These are the same. The top one's just mathematically better than the other one. I mean, as far as what mathematicians would use, it's mathematically the same, but we like this one better. So there's the right, and then the graph. These are some pretty funky numbers. So I'm going to count by negative 150, negative 50. Oh, wait, negative 100, negative 50, 0, positive 50. So there's a 0, there's negative 100. Maybe I can write them all slanty. There, looks a little bit better. Okay, so I'm counting by 50s, because these numbers are fairly far apart. I've got to count by something bigger than 1s and 2s and stuff. So that would put negative 133 here-ish. And that would put positive 27 here-ish. And the reason why I'm numbering is because, well, that's not exactly positive 27. And I want to make people understand exactly what that number is, and that number is. And since it's an and inequality, we should be shading on the inside. So there we have it. Understanding that the temperature would be between those two makes us an and. And it actually does say the word and. Spider-Man has either knocked out less than 20 bad guys or more than 85. He got hit on the head by Dr. Octopus and lost his memory. So write and graph an inequality for the number of bad guys Spider-Man knocked out. Go ahead, this one's for you. Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so either less than 20 or more than 85. And it's an or, so, you know, I'm just gonna, that was weird. All right, whatever. We'll live, we'll make do. We can write it like this. So, or. There's no solving needed in this. It was just writing the inequality, and now we graph it. So we need what? What scale? Like 0, 10, 20, 30, 40. 10s isn't going to work. 0, 20, 40, 60, 80. 20s is not going to work. Unless we put 20 on the edge, which is not horrible. I mean, I suppose we could. 20, 40, 60, 80, 100. It's probably better than counting by something like 40s, but I mean, it would work as well. So then 20 would get a hollow dot. 85 would get a hollow dot. And then the shade. It's an or, so we should be shading on the outside, but let's check. Less than 20. Bigger than 85. Boom, boom. So yeah, we're shading on the outside. Summary. How do you solve compound inequalities? So think about it. That's the essential question. Put down a thought. How did we solve them? What are some things that you would recommend? There's some things you would tell other people. You explain to your younger brother and sister or mom and dad. How do you solve compound inequalities? Go ahead and pause the video and think about it. Okay, so I was thinking things like and inequalities get shaded on the inside, or inequalities get shaded on the outside. Things like both inequalities get graphed on the same number line. Oopsie. But the dots don't have to be the same. Maybe you can mention about if you have something like 3 is less than 2x is less than 9, something like that, how you can just kind of keep it all together as one problem and solve it like that. So like these are just like thoughts. And inequalities or inequalities. The dots don't have to be the same, but they're graphed on the same number line. And inequalities could be solved like this. I mean, it's really just, it's two inequalities together. So there's lots of things we learned about in this lesson that you could put down here. Okay? Thank you so much for watching. And until next time, toodles.